So finally we made it to radian measure. We are going to be talking about how to change from degrees to radians and what radians are. Radians are really important because when you get into calculus, measurements in calculus are so much easier in radian mode than they are in degrees. So we need to transfer how to use and know how to use radians instead of degrees. So we are now going to focus on that. So you're probably asking yourself, where does radians come from? And so what radians come from is the unit circle that we talked about before. And so if we look at the unit circle, when you have this, you're going to have an angle theta, and then you're going to have a radius. From this radius, we are going to then, if it starts down here from the point that it starts to the point it ends, it makes an arc length. And so the arc length we call S for arc length. Makes sense, right? So when you do this, the formula that we have here is going to be that the arc length is going to be equivalent to the theta times the radius. So what happens is that if I want to actually know what the angle is, I solve for theta and I get theta by itself, and I divide both sides by r, and I get S is divided by r. When S and R, the radius and the arc length, are the same length, that's when it becomes, they're going to cancel, and I'm going to get 1, and what it actually becomes is 1 radian. So 1 radian is a little less than about 60 degrees. So that's in the unit circle, it's a little bit less than 60 degrees. So 1 radian is quite big when the degrees is almost at 60. So the degrees are smaller units than the radians are. And you've been using radians for a while, you probably don't realize it, but when you talk about area of a circle, the area is 2 pi r, and we're going to be using pi a lot in here, and that's one way that we measure radians on there, but this here is radian mode. And when you do the circumference, I'm sorry, I said that wrong. I did the circumference formula instead of the area. It's pi r squared, and then this is going to be 2 pi r. But they're both circumference, they're both radian measures. We're using pi, and then the pi that we know, probably you know once around the circle is the 2 pi, and the size of the circle depends on the radius. So that's where the 2 pi. So half around the circle is going to be pi. And so if we actually divide it, a quarter of the circle is going to be pi divided by 2 because it's half of the pi. And then this one's going to be 3 pi over 2 because that's in the middle of it. So we start at 0, pi, half a pi because it's half of this. And then this is 3/4 of the way. And then this one here is the full 2 pi. So those are things that you probably already know, which we're going to apply into the unit circle. So you should know all this stuff already on there. We've already talked about it. And if not, make sure that you do know it because we're going to add to it. It's a very colorful circle. And one of the things you need to focus on are the blues and the yellows. Notice how the blues are all the 30s, the 60s, and the 90s on there. And the yellows are going to be the 45s plus the quadrantal angles. The quadrantal angles are shared by the 45s and by the 30/60s. So those are the ones that are always going to be shared, and these are going to be a little bit different on there. So the first thing we need to talk about is the radian measure and how we are going to convert it. And the way you convert it is by using the dimensional analysis where you have the 30 degrees over 1 and then times, and then we're going to compare where I have degrees here and I am going to have radians up there because that's what we want to cancel. So we need to know a relationship. And the relationship here is you could use any relationship, but the easiest relationship to use is that 180 degrees is equivalent to pi. So I'm going to do 180 degrees and pi. And so that's going to cancel. The zeros are going to cancel. That's going to be there. The pi is going to be, I don't know where it's going there. And everything just cancels. Okay, so we're going to have this to be pi over 180. And so what happens here is that they're going to cancel, and I am going to let pi over 6 radians. So now we know that 30 degrees is equivalent to pi over 6, and that's really all we need to know to be able to fill out most of this circle here. So I'm going to do this in A little bit of red on there. So what we know here is that the 0 degrees is still going to be 0 radians. Notice how this is degrees. If I do not put degrees on there, I am going to assume that they're radians. So that's going to make a difference on there. So this is just 0 radians. And so the first one we already figured out is going to be pi over 6. So we know it's going to be pi over 6 there. And so what we're going to do is only the blue ones, the ones and the quadrantal angles are going to be counted. So we're going to do pi over 6. This one here is going to be pi over 2 pi over 6, which ends up going to have to reduce it to pi over 3. This one's going to reduce again, and we're going to do this as 3 pi over 6, which is going to reduce to pi over 2. This one's going to be 4 pi over 6, and that's going to reduce to 2 pi over 3. This one's going to be 5 pi over 6. This one's going to be 6 pi over 6, which is then going to reduce to just pi. And then this is going to be 7 pi over 6. This is 8 pi over 6, which is going to be 4 pi over 3. 9 pi over 6, which is going to be 3 pi over 2. And then 10 pi over 6, which is going to be 5 pi over 3. And then 11 pi over 6. And then this one here is going to be 12 pi over 6, which is going to reduce to 2 pi. And so that's how you count by pi's over 6s all the way around, and it includes the pi's over 3s, the pi's over 6s, which is the 30s and the 60s on there. So the other thing is now we're going to do the 45s. The 45s are going to change. We're going to have 45 degrees to change it to 180, and then pi radians, and the degrees cancel, and so the 45s is going to be 1.5 radians. So 45 degrees is equivalent to pi over 4. And so we start counting again. All the quadrantals are included. So this is pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and this one here is going to be 8 pi over 4, which ends up being 2 pi. So that's how you convert to radians. So radians has come from this formula, S equals to theta r. Once you reduce it, you get 1 radian. We convert the degrees to radian mode by using dimensional analysis, but the easier way is knowing the first two, the 30 and the 45, and then you could count around the circle. The trig ratios do not change. The signs of the trig ratios do not change on there. And so everything else still works the same. The only thing is the radian measures. And it's going to make things a little bit easier also. At the beginning, it's going to seem a little tough, but then it's going to be, the more you use it, the easier it'll become. And so that would be it.